All right, welcome to your next section, Algebra 1, Chapter 4.6. We're going to be dividing polynomials. Let's get started. Okay, let's take a look. We have here a polynomial divided by another polynomial. Notice that the powers on the polynomial in the numerator are higher than the powers of the variable p in the denominator. So here we're going to have to do long division. You'll start to get used to how to recognize these. Really, it's just looking at the powers. P to the third, p to the first, long division. So like in elementary school, we would always take the number in the denominator, put that outside, have this little liney thing here, and then take what's in the numerator and put that on the inside. Now, what I think is easiest about this is really you're always going to just look at the leading term in this polynomial, and you're going to look at the leading term in this polynomial. In this case, we just have one term, but you're going to have to ask the question, what do I have to multiply this by in order to get this? And over here, I've put on my little side work here, I've said, hey, what do I have to multiply by 3p in order to equal 15p cubed? Now this really is just a math problem because I just need to divide both sides by 3p and I'll get what my question mark is. So here I have a 5p squared. Now I'm going to take my 5p squared and place it right above our first term, because just like in elementary school doing long division with just numbers, we're going to end up saying, hey, this times this is going to give me this, but then we're going to have to say this times something will get me. Correction. Let me continue with this problem and show you. And again, just like in elementary school, this times this is going to give us this, 15p cubed, and we're going to minus it, giving us a 0. And then again, recall what we did in elementary school. We had to bring down the next term, or the next digit. In this case, it's a term. So I brought it down. Now I'm going to repeat what I did here. 3p times something is going to give me 18p squared. So here's my little side work. Something times 3p will give me 18p squared. Turns out that's going to be a 6p. So that's what I'm going to put here, 6p. Now 6p times 3p is going to give me my 18p squared. I'm going to minus it and I'm going to get a 0. Now here I'm just left with the 0, so I don't have a remainder. So this is my final answer, 5p squared plus 6p. But one thing I do want to note to you, when you get a problem like this, if you jump right into it and do your long division, that's fine. But in the future, you're going to look at a problem like this and really you want to think this way. Notice all I've done is I've just separated my two terms in my numerator and kept my same denominator. Here things end up canceling out to 5p squared. Here things end up canceling out to 6p, which does get me the same answer that I found up here. We're going to go through a lot of problems with long division. I'm going to do those now. So just be aware that this is going to be easier than doing long division, but we still need to learn how to do long division. All right, here's my next problem. Negative 9x to the 4th plus 18x to the 5th, all divided by 6x to the 5th. So I am going to do my long division, but I'm going to make sure that my 18x to the 5th is put in the leading position. All right, so here I've rewritten my equation. So the question I have to ask, what do I multiply this by in order to get this? I put my little side work over here. It turns out to get a 3. So I'm going to go ahead and write my 3 here. Do my operation. 3 times 6x to the 5th gives me a 18x to the 5th, and I'm going to minus it. I'm going to bring down my negative 9x to the 4th. Well, I need to recognize something here. Because the power is less than the power I'm going to work with, this turns out to be my remainder, and my remainder is always divided by what my denominator was. So what am I talking about? This operation shows that 3 plus the remainder, the negative 9x to the 4th, let me rewrite my 4, is in the numerator, and here is the denominator. Now I'm going to clean this up a bit, and here's what I get. My negative sign comes out. I have a 9x to the 4th over 6x to the 5th. Now I can cancel some x's here. I can cancel all 4 of these with all but one of those. And doing some quick head work, this turns into a 3 times 3, this turns into a 3 times 2. I'm going to cancel some 3's. And ultimately, this is my final and correct answer. Notice I still have an x on the bottom there. Okay, here we go. We have a negative 9x to the 5th plus 3x to the 4th minus 12, all divided by 3x to the 3rd. Notice the powers. I have an x to the 5th on top, an x to the 3rd on the bottom. So let's attack this with long division. All right, so here's my setup. And again, we're going to start with our leading terms here. I need what times 3x to the 3rd will give me negative 9x to the 5th. Again, what times this will give me this? Well, after doing my work, I get negative 3x squared. So when I do my multiplication and I minus, I end up adding. And bring down my next term. Let's see, what times this will give me this? That should be some quick head work. It's just x. Multiplying this out and minusing, then bring down the 12. Now at this point, notice my x's are nowhere near this amount, so I can just take this as my remainder, put it over on my numerator, and see what cancels out. Alright, so I have this here, and then my minus 12 divided by my denominator. Turns out that I believe a 3 is going to cancel. And this does become my final answer, negative 3x squared plus x minus 4 divided by x cubed. All right, folks, we're going to continue. This was chapter 4.6, so next section is 4.6b. See you there.